Hello everyone, this is Jeon. This course is Introduction to Computer Networks. My name is Jeon. Today we will study Chapter 1, Introduction. In Chapter 1, Introduction, the goal of this chapter get a big picture, introduction to terminology. More depth, detail later in a course, so we can study in more detail later on. The approach is we'll use the internet as example. Overview and roadmap. What is the internet? What is a protocol? Network edge, network core, performance. And then we'll tackle security, and we take a look protocol layers, concept, and service models, and we'll see history of the internet. Okay, the internet, a nuts and bolts, the components of internet. You can see we have many kinds of devices. It is called host or end system. Learning network applications on top of end system. And also we have packet switches to power the packets that are chunks of data, such as routers and the switches. So we have many kinds of packet switches. Also communication links, fiber, copper, those are wired communication link, and radio and satellite, they are wireless link. Transmission rate means bandwidth, speed of communication link. As you can see, the network are collection of devices, routers, and links. Those are managed by an organization such as SKKU. So right hand side we have a figure represent network, mobile network like 4G LTE, 5G, something like that, and also home network using Wi-Fi, wireless access point, and also enterprise network, campus network like SKKU network. In the middle we have core network, okay, so local or regional internet service provider network, or national or global ISP. Also content provider network like Google, they running data center network. So upon internet connected devices, we have many kinds of devices like this, okay? So one of interesting devices is this weather forecaster toaster. So depending on today's weather, cloudy or sunny, okay, shape made. So internet is a network of networks, okay? So interconnected internet service providers. Protocols are everywhere. They are control sending and receiving of messages, such as hypertext transfer protocol for World Wide Web, streaming and video service, Skype for voice over IP, and TCP IP, Wi-Fi, 4G, and 5G, and Ethernet. So those networks are construct the internet. Also, each end system can communicate with other end system or router system using protocols, okay? So language for computer network systems. Those protocols are standardized by Internet Standards Organization such as IETF. IETF stands for Internet Engineering Task Force. The RFC is a standard document, stands for Request for Comment. ISG, this is committee to standardize and finalize Internet draft as RFC. It stands for Internet Engineering Steering Group. Infrastructure provides services to application. World Wide Web, streaming video, etc. Many kinds of applications are provided using this infrastructure in the internet. It provides programming interface to distributed applications like API application programming interface to make it easy for programmer to program for network systems or applications. What's a protocol? It is like a human protocol. What's the time? I have a question. Introduction. Okay. So network protocol is used to language let computers or devices can communicate with each other, or communication activity in the internet is governed by protocols. Okay, protocols define the format, order of messages sent and received among network entities and actions taken on message transmission or receipt. So we have the example, Alice and Bob can communicate with each other. Hi, got the time, 2 p.m. Other human protocol. In the similar way, this desktop and the server can communicate, set up TCP connection using TCP three-way handshaking, and then after that we can get web page using HTTP. HTTP stands for Hypertext Transfer Protocol for World Wide Web. Next is network edge. Okay, so network edge case. So we have and the system here. So these are called edge. We have a host for client, also server. And server often located in data centers like Google, Amazon, something like that. Access network is this network, 5G or 4G LTE or access point, while the system case, router and the switches providing wired or wireless communication links to network systems. Network core is a core network, connect edge or access networks. How to connect end system to edge router? So we can use a residential access network or institutional access network, like a school and a company or university. Or we can using a mobile access network like Wi-Fi, wireless LAN, or mobile networks such as 4G LTE and 5G. What to look for? Transmission rate. It is bits per second. How many bits can be transmitted per second of access network? So those link can be used shared way or dedicated way. One access network is cable-based access. Okay, so many houses are connected cables. Okay, so cable and the system collect cable and system. So video and data control channels are divided, so it is called the channel division or frequency division multiplexing. Different channels transmitted in different frequency band. Also, we have CMTS. Okay, stands for cable modem termination system. So this system interconnect or houses cable network. Okay. So HFC stands for hybrid fiber coax. This is coax cable, asymmetric, up to 40 megabps and 1.2 gigabps downstream transmission rate, and 30 through 100 megabps for upstream transmission rate. So network cable fiber attaches homes to internet service provider router like KT, LGU Plus, or SK broadband, something like that. So homes share access network to cable endpoint. Okay. So we have another access network is digital subscriber line DSL using telephone line. So DSL modem shares a telephone line for voice service and data service. Okay, so use existing telephone line to central office DSLM. DSLM is DSL, digital subscriber line access multiplexer, which means many houses are connected to this DSLM. Okay, and then DSLM eventually connected to ISP core network. Okay, data and voice, they are going to separately. Data over DSL phone line goes to the internet. On the other hand, the voice over DSL phone line goes to telephone net. Okay, and then 24 through 52 megabps dedicated downstream, and on the other hand, 3.5 through 60 megabps dedicated upstream. Okay. So another access network is wireless LAN, also using some simple some switch. Okay. So this house is connected to head end or central office using cable or DSLM modem, and then behind cable or DSL modem we have a switch or router providing firewall service to protect the attack from the hackers. NAT, network address translator, provide private network. Okay, and while the Ethernet is usually 1 gigabps speed, and the Wi-Fi we are using 11G, 11N, depending on version of Wi-Fi, so we can provide 54 or 450 megabps service. Okay, so many kinds of wireless devices can connect it to Wi-Fi. Okay, or this one connected to LTE or 5G directly. So wireless access networks share the wireless access network connect end system to router using access point. This is base station. The AKS stands for also known as so wireless local area network and wide area cellular access network. We have two kinds. Okay, so this local area network LAN for home, small place or small the office. On the other hand, the cellular network case coverage is larger than local area network. Okay, so this is coverage 100 feet. On the other hand, cellular network is 10 kilometer. Okay, and the speed out to the 11. This is IEEE wireless LAN standard. Okay, so B 11 megabps, G 54 megabps, and 450 megabps transmission rate. On the other hand, the 4G LTE case 10 megabps. LTE stands for long-term evolution for 4G. Second, fourth generation for 3GPP network. And 5G cellular networks usually 100 megabps, 10 times of 4GLT. Okay. Another access network is enterprise network like a campus network. Many network switches or router are used to connect access network, okay, in the campus department. Okay. And the host sends packets of data. Okay, host sends packet. So in that case, we can calculate transmission time. Okay, so if the packet consists of length L bit and transmit a packet into access network and transmission rate R is bandwidth, and link transmission rate also known as link capacity, link bandwidth. Okay. In this case, we can calculate a packet transmission delay is time needed to transmit L bit packet into link. So packet size L bit divided by the transmission speed, transmission rate R bit per second. Okay. So bit physical link, guided media, unguided media. So the bit is propagate between transmitter and receiver pairs, and the physical link what lies between transmitter and receiver. Physical link may be wireless in Wi-Fi, wireless LAN environment, or it wired link case in the Gigabit Ethernet. Guided media case, signals propagate in solid media such as copper, fiber, coax. On the other hand, unguided media usually wireless signals propagate freely, like radio. And one of wild technology twisted a pair TP to insulated copper wire, physically separated copper wire, category 5, category 6, different speed of Gigabit Ethernet or fast Ethernet service provided. This is RJ45 cable, okay, for twisted pair, and coaxial cable for cable network. Okay, this coaxial cable. Okay, and the fiber optic fiber network, such as Gigabit Ethernet or 10G or 100G Gigabps case cable case fiber optic is used. Okay, and physical media case, we can have wireless radio or radio types here. So usually wireless radio case, the signal carried in electromagnetic spectrum. There is no wire. So we can perform broadcasting and have a duplex communication. Propagation environment affects reflection, obstruction by objects, and also there is interference factor should be considered. Radio link type case, terrestrial microwave up to 45 Mbps channels are used, and the wireless LAN or called Wi-Fi up to 100 Mbps usually, and the wired network case, cellular network, 4G cellular case up to 10 Mbps, 5G case 10 times, such as 100 Mbps. Also nowadays we are using Starlink. Okay, so in that case satellite are used for interconnect satellite. Okay, so up to 45 Mbps per channel, 270 millisecond end-to-end delay, and geosynchronous versus low Earth orbit depending on the height of satellite. Next, network core. So network core case packet switching or circuit switching. So, but in internet case, usually we are using packet switching. Okay, so host like application layer message into packet. Okay, so the packet is forwarded by router to next router. So like this packet delivered here, core network, they are forwarding. So routing information exchanged using a border gateway protocol BGP. And packet transmission, store and concept is used. So this desktop transmit 1 to 3 packet into this network toward destination case. Transmission delay, store and forward end-to-end delay we can calculate. Transmission delay is the time deliver whole message L, okay, using transmission rate R. Okay, so in that case L divided by the R seconds, okay, to transmit L bit packet into link at RBPS bandwidth. And store and forward case, entire packet must arrive at router before it can be transmitted on the next link, such as CRC check or checksum to validate the correctness of bit. And end-to-end delay is, so from here to here is one-way end-to-end delay. Okay, so but end-to-end case two-way round trip. Okay, so in that case 2L, this length divided by R, assuming 0 propagation delay. But in reality we have propagation delay exists. Okay, one of numerical example, the message size L 10k bits and transmission rate R 100 Mbps. In that case, one hop transmission delay is L divided by R. Okay, and the packet switching, queuing delay and loss. So the switch or router has queue for packet, so they're physically waiting for each turn of transmission. So packet queuing and loss. If arrival rate in BPS to link exceeds the transmission rate in BPS of a link for a period of time, packet will queue waiting to be transmitted on output link, or packets can be dropped, lost if no available memory place for packet. Okay, so memory in the router fills up. Next, two key network core function. One is routing, the other is forwarding. Okay, so routing is exchange route information among router to make a forwarding table. Supporting table is the packet is comes in and then select which next hop router or switch is for next step. Actually, routing case we are using router rather than switch. Okay. Supporting is a header, usually destination header. IP version 4 case 32-bit address is used to select the output link. Okay. And alternative to packet switching is circuit switching. So end-to-end resource is a reservation. In the past, ATM, asynchronous transfer mode, this is reserve some bandwidth, some trunk and circuit. Okay. So we have multiple such as 4 circuits, and then we can reserve one circuit for such as some from this desktop to another desktop pair. So circuit switching case, we can sharing the bandwidth using FDM, frequency domain multiplexing, over time domain multiplexing. Okay, so frequency case, over time frequencies are divided in the each user allocated a different frequency channel. On the other hand, the time division multiplexing TDM case, we make a time slot and then whole frequency are used for each time slot. So we can compare between packet switching and circuit switching. Okay, so packet switching allows more user to use network because some user over end user, some user either case, other user fully utilize network bandwidth. So if we are using a circuit switch, we divide by the n, small link bandwidth is used. Okay, so example 1 gigabps per second link. Each user is active case 100 megabps. Okay, because we have for example the 10 user case, active time is 10% of over time. So circuit switching 10 user, packet switching case, if we have 35 users, because active time is 10%. Okay, so simultaneously access some link, and probability we can calculate. Okay, and then 35, and then and then 10% is how many percent people? 3.5 over time. Okay, so almost in that case, so more than 10 access probability is we can calculate. Consider this combination less than 0.0004. Okay, and then if we can change a little bit formulation. How did we get value 0.004, and what happens if access active number is more than 35? So how can calculate? Okay, this is for your task mission. Okay, so please check the online interactive exercises for more information using this URL. So packet switching and the circuit switching case, who is winner? So packet switching usually a slam dunk winner or not. So bursty data case is great. Okay, so sometimes has data to send, but at other times not. So resource sharing is good, and the simpler no core setup procedure. On the other hand, the circuit switch has the resource case allocation, and core setup is used to guarantee required bandwidth. The excessive congestion, possible packet delay and loss due to buffer overflow, and protocols are needed for reliable data transfer and congestion control in packet switching. The question is how to provide the circuit-like behavior using packet switching. So bandwidth guarantees traditionally used for audio-video applications, and human analogies of reserved resources is circuit switching versus on-demand allocation packet switching. This is a comparison between packet switching and circuit switching. Okay, so dedicated copper path, some circuit. Packet switch, there is no dedication circuit path, and according to routing update, packet follows that new routing path. The circuit switch case initial setup make sure dedicated path is reserved, and the bandwidth available case. So packet switching speed is dynamic, but circuit switch is fixed for each end system, and the potentially wasted bandwidth is less as long as some the end system using considering maximum bandwidth. So wasted bandwidth no, because they try to utilize fully. For circuit switching case, they just specified at the beginning bandwidth is used. Sometimes the host doesn't send, that channel is wasted. Store and forward. Packet case, core packet is transmitted to next router and then wait the last bit of packet to calculate the CRC, cyclic redundancy check code, to protect the bit error, or checksum to check IP or TCP UDP header corruption of a bit. Circuit switching case, there is no such kind of thing. Okay, just transmit. Okay, so there is no waiting, and each packet follows the same route. No, depending on a network condition and routing protocol can change. However, circuit switch case, the initial setup path is used. Core setup is not needed by packet switching, but required by circuit switching. When can congestion occur? Anytime, anywhere, which means on every packet can experience congestion. On the other hand, the circuit switch case at setup time to consider resources, congestion can occur. Effect of a congestion, queuing delay, eventually packet loss or delivery delay happen. On the other hand, circuit switching has a code blocking until new resources is released for other connection. Internet structure. Now we can see a network of networks. The hosts interconnect to internet via access. Internet service provide ISP network like residential ISP network, enterprise network, ISP. So access internet service providers in turn must be interconnected. So any two hosts can send packet to each other. Resulting network of network is very complicated. So evolution was driven by economics and national policies. Let's consider a stepwise approach to describe the current internet structure. So this is the given networks. So the question is how to connect the millions of access networks are connected. So if we are using each connection, so many link, the complexity is O, big O, and square connections. So and choose two links are n square, right? So complexity. So the other option is we can using global ISP. So in that case, one complicated ISP used, but this is hard to construct or manage. So we split the many internet service provider A, B, C, something like that. This is also we can connect ISP network using internet exchange point. Also peer link directly router can be connected. Also under ISP we have a small regional ISP can be used. Also content provider network, data center network like Google, YouTube network, or Netflix network can be used. So internet structure, we have a tier 1 ISP, tier 2. Tier 2 is a kind of regional ISP. So their ISP and network connected ISP internet exchange point or dedicate a line link. Also Google is the level is similar to tier 1 ISP. They providing their own private network that connects its data center to internet, often bypassing tier 1 regional ISPs. So this is a tier 1 Sprint network. This is United States. So many the Sprint nodes are interconnected here. So the concept POP, point of presence. Okay, this group of routers. Okay. Let's move on. Performance loss delay throughput. So this is a network, typical network. So arrival rate is exceeds uplink capacity. Packet loss happen because the many packet queued up, and then the queue is limited resource, and then if there is no room, the packet randomly dropped. Okay, so and also it experiences queuing time means transmission delay happen here. Also packets in buffer queuing delay happen. So transmission delay and queuing delay. So there is no free buffer means packet should be dropped. So packet loss happen. So we can calculate nodal delay. So from nodal delay case from the transmitter recipient some network system or destination delay we can calculate. First okay, here let's calculate from this router to this router. So transmission packet transmission delay is required. Okay, but from here to okay, here, so transmission delay, also propagation delay here. Okay, but using this pair case, transmission delay, propagation delay, also loader processing, calculate. Okay, checksum, routing lookup, it is a nodal delay. Also queuing for delivery of other package. Okay, so processing delay, queuing delay, and transmission delay, and this propagation delay. Okay, so this is nodal delay in the intermediate systems delay. So nodal processing check bit error like checksum or CRC, also determine output link or output port, typically less than millisecond. And the queuing delay is time waiting at output link for transmission, depending on congestion level of router. Many packet also delivered shared link case, routers need to compete. Okay. So the transmission delay we can calculate. Okay, here message or packet size divided by the bandwidth is R, and the propagation delay is this is distance. Okay, physical link distance divided by propagation speed. Ethernet case, you can see 2 times 10 to the raised by power 8 meter per second. Okay, so and the carbon analogy is we have 10 car, so we can say 10-bit packet. So okay, 10-bit packet arrive at turbos is router, and then next router turbos case, how can calculate the nodal delay we saw, right? So and this distance between toll buses is 100 kilometer, right? And then each toll service time, transmission time is 12 seconds. Okay, so how long until carbon is line up this one? Okay, so in that case, transmission pushing time is transmission time 12 seconds times the number of the cars 10, right? So this is pushing transmission time, and then after that last the car bit propagate. Okay, the other side turbos case propagation delay, the length d 100 kilometer divided by speed is propagation speed is 100 kilometer per hour, right? So we divide by this, and then we can get the last this car turbo time is 1 hour, so we can sum up this one. So this is 60 minutes, this is 2 minutes, right? So total is 62 minutes. And we have changed a little bit. So propagation speed is 10 times 1,000 km per hour. Okay, and then deliver okay 12 boost service time 1 minute. So previously 12 second 1 minute case. Okay, so in that case the question is will cars arrive to second boost before all cars service at first boost? So all car solved by the first boost and the car will arrive second boost or not. Okay, yes. After 7 minutes, first car arrive at second boost. Three cars are still at first boost. Okay, so we can calculate this one according to this one. Okay, so first car passes through the first boost 1 minute, right? This is transmission delay, and then it runs through the highway. This over this link 100 kilometer speed is this 1,000 kilometer per hour, right? So we length d divided by the speed of this, and then 0.1 hour. 0.1 hour means 0.1 times 60 minutes is 6 minutes. Okay, and then 1 and 6 minute time first car arrive at second boost. So in that case, how many car serviced by this? 7 minutes per one car serviced by 1 minute, right? So 7 minutes, 7 cars. So which means 3 car left. Okay, at first boost. Let's move on. Packet queuing delay. So this curve showing traffic intensity. Okay, the intensity means traffic volume or density. So the L is the packet length and the packet arrival rate. A, the times is actual unit time. So these kinds of packets arrive at router. And then service rate is R. So this is okay. So if this denominator R is larger than this numerator case, no problem, right? A small case fine. But close to 1 case, problem happen. So 0 case, queuing delay small, ignorable. And close to 1 case, you can see close to, queuing delay larger. It's close to 1 case, the infinite, okay? More than 1 is the serious, okay? Average delay is infinite. So you can see we have analogy in the highway. So pure number, okay? Arrival rate is almost 0, but this is high, is close to 1 case. The each car delay is in the highway road segment is close to large delay. Let's move on. Real internet delays and the router. So we measure from here to here the end-to-end delay using trace router program. Okay. So we can calculate time to leave field value to calculate round trip time. So using TTL, set up 1 case. It is delivered here, divided by decreased by 1. So TTL value becomes a 0 case. The router delete and then generate the error message. TTL expired. Okay. So and then the ICMP error message, internet control message is ICMP. Okay. ICMP, internet control message protocol. So and then receive timestamp difference is round trip time. And then next time this host increases TTL by 1, which means 2. So this decrease by 1, TTL becomes 0 and generate. Okay, using this one we can measure. And then destination case, the UDP, some destination is a random port, and then this guy is generate unreachable port or something like that, and eventually it can get the the similarly error message and calculate the transmission time and the receiver time is two-way round trip time delay can be calculated. Okay, something like that. This kind progressively. So trace root you can using Windows case trace root or trace RT and then serial prove. Okay, from this is a gateway and then this is other network intermediate routers. The stars case means no response, which means the ICMP error message not generated. Okay, and then eventually okay, Fantasia Eurocom, this one is reached okay close to this URL okay web server. And packet loss case, this figure shows situation. So buffer is occupied fully and then more packet, there is no room, in that case randomly okay drop, okay, or drop okay the last arrival on it, okay drop or first one. So depending on buffer management policy, we can handle buffer okay full up cases. So the throughput is late bits per unit time at which bits are being sent from sender to receiver. We have two kinds of throughput: instantaneous, late at a given point time, or average, some certain period of time. Okay, so this is server, this is router, link. This is the host. Okay, so this link is a kind of pipe is narrow link, lateral pipe. This is a wide. Okay, so in that case, this service link, this client link case, service link is less than client link case. What is average? So this bottleneck link determine. Okay, similarly, bottleneck determine and the delay. Okay, so link end-to-end path that constrains end-to-end throughput is bottleneck link. And let's move on. Throughput network scenario here. 10 connections. Okay, share backbone. Okay, here link R. Okay, so client link, server link, and then core network divided by 10 minimum. Bottleneck link decide over throughput. So security. So the network security is about how bad guys like hacker can attack computer networks. Secondly, how we can defend our networks against security attacks. Thirdly, how to design architectures that are immune, safe from the attacks. Okay, Internet is not originally designed with much security in mind. So original vision, a group of mutually trusting users attached to a transparent network, but it is not nowadays. Okay, many hackers okay makes malicious activities. Internet protocol designers playing catch up, and then security considerations are designed and implemented in all layers. So bad guys, okay, malicious software called malware. Malware can get in a host using virus of worm. Virus is a self-replication impact by receiving execution object, such as email attachment. Okay, but virus should be sent from computer to another computer by user or software email. Okay. On the other hand, one case, self-replication. This is similar by passively received object that gets itself executed. So one can self-replicate and spread to other computers, but virus cannot spread by itself. Okay, so worm is a kind of used for denial of service kind of attack. Okay, So spyware malware can record the keystrokes in keyboard, website visited, upload information to collect the site or user. Impacted host can be enrolled in botnet. Okay, botnet is used for spam or distributed general service DDoS attacks. Okay, so DOS. Have you heard of DOS? Denial of service. You can see the target victim. Okay, so select, and then others. Many hosts are, impacted by malicious malware, and then break into host around the network. Okay, botnet. Make some garbage traffic. The target cannot work. Another concept is sniffing. Sniffing is a listen, over shared Ethernet or wireless LAN. So promiscuous network interface can read or record packet. Okay, so read. Okay, this is a passive attack. So Wireshark is one of packet sniffer. Okay, to capture packet. The other one is IP spoofing case, changing something. So IP spoofing case send the packet with the first source address. Okay, so pretend to be B. Okay, C using B's address rather than his own IP address. So lots more on security. Throughput is considered by chapter 5 security chapter. Let's move on. Protocol layers and reference models. Networks are complex with many pieces like host, router, links, application protocol, and hardware, software, etc. The question is there any hope of organizing structure of a network, or at least our discussion of networks? So let's look at concept of a protocol. So we have a procedures, right? When you going to some foreign country like United States from Korea, you need to buy ticket, and then you can check in. You can load the luggage front desk in airport, and then gate. Okay, you can prepare loading, and then take off airplane route according to route, and after loading, and then it arrive at destination airport, right? So in that case, the landing and then unloading, and then you are going to basic claim. You can get back your baggage, and if you have some ticket or mileage not accumulated, you can complain. So airline travel is a series of steps involving many services, right? So we can make this kind of service steps into layer like this. Okay, so airplane routing is packet routing. Airplane is a kind of a bunch of packet, right? Each person is some bit. So each layer implements a service via its own internal layer action, relying on services provided by layer below. So routing service, runaway service, gate service, baggage service, ticketing service. Okay. So why layering is used in the network? So we can deal with the complex system. So explicit the structure allows identification relationship of complex system pieces. It is called reference model. So if you make whole network functions one layer, some problem happen, it is very difficult to debug, also maintain. So also if you invented a new some transport layer protocol, you just replace existing physical layer, data link layer, network layer can be reused. Okay, so modularization eases maintenance update of a system, and later consider the harmful optimization point of view. Cross layer, especially wireless network case, physical layer, data link layer, network layer can be interact it is called cross layer. But wired network is usually splitted, stacked. Lateral model is good. Okay. So internet protocol stack, we have these kinds of stack: physical layer, link layer, network layer, transport layer, application layer. So usually link and physical layer, we can say Ethernet, Wi-Fi, and network is IP or IP version 6. Transport layer is TCP, transmission control protocol, or UDP, user datagram protocol, SSTP, message, stream, control, transmission protocol, SSTP, and HTTP for World Wide Web, hypertext transfer protocol. So source message is according to this message protocol stack, and then each layer has a header or tail for Ethernet case, and the message is delivered from here, and then attach transport layer TCP header, and the network IP header attach, and then link layer case attach link layer, and tail is CRC, and then physical layer delivered. Okay, and then according to, so switch is L2. Okay, L3 case looking up router next hop. Okay, and then deliver network layer, also decrease the time to live TTL value. Okay, and then update the link layer next the hop the Ethernet destination address, and then deliver to destination. And then packet alive here, it is called a frame, and then detach header frame layer 2, and then network layer detach network header here, and then transporter header also detach, and then final message alive at destination. Okay. The last part of this section or today's class is internet history. So 1961 through 1972, this is in the beginning of some packet switching. So all the packet switching principle. Okay. So Kleinrock, he is a professor. So he designed the packet switching based on queuing theory. Okay. And then Baron made packet switching in military network. And then 1967 ARPANET. This is the military network ARPANET, conceived by Advanced Research Project Agency. And so 1969 first ARPANET node here. So first ARPANET network is interconnect UC Santa Barbara, UCLA, and Utah. Okay, University of Utah. And then 1972, so ARPANET public demonstration done. NCP, network control protocol, is used to host-to-host communication. And first email program is implemented, and the ARPANET has 15 nodes. So ARPANET here. So this is ARPANET. So Honolulu in Hawaii, and we have the USC, University of Southern California, UC here, UC universities, okay, and the Utah, University of Utah, and the Purdue University, and MIT, and Carnegie Mellon, Rutgers, okay, university, something like that. So usually at the beginning of ARPANET, interconnect the university network and some research lab. So this is ARPANET logical map, March 1977. Okay, so you can see Hawaii, Honolulu. Okay, and then we can see UCLA network, USC, University of Southern California, and MIT, and Harvard, New York University, many network, and Texas, okay, like Texas, Austin, something like that. So 1972 through 1980, internet is this is a very important area. New proprietary network invented. So Aloha, this is a satellite network in Hawaii invented, and Khan and Bin Cerf and Khan made the architecture for interconnecting and the network. Okay, and then here Cerf is the father of internet, and Cerf and Khan's internetworking principle is minimalism, autonomy, no internal changes required to interconnect networks, and best effort service, not quality of service, stateless routing, not stateful routing, and decentralized network. So the packet switching is invented in the United States, competed with the Soviet Union, nowadays Russia, right? So in that case, Russia missile attack, and then circuit switching case, whole network is paralyzed. But packet switching case, running packet routing protocol, it can survive. That is the principle of packet switching. So this is to define today's internet architecture. Okay, and then Xerox in the California. Okay, so they made Ethernet. This is very important invention. Okay, and then so ATM, asynchronous transfer mode, precursor. Okay, this is a quality service. Okay. Next period, 1980 through 1990, new protocol of proliferation of networks. Okay, so TCP/IP deployment happened. SMTP for email protocol. Okay, simple message transfer protocol is invented for email delivery, and DNS, domain name system, for name to IP address translation, and file transfer protocol, TCP congestion control invented. So, and then new national network like NSF network is constructed. 100,000 hosts are connected to compilation of network. Okay, so this is NSF network. Okay, National Science Foundation network here. So many cities connected using these kinds of network links. And then 1990 through 2000s, commercialization, e-commerce, World Wide Web, new applications are invented. Okay, so early 1990, ARPANET commissioned for that NSF lift restriction on commercial use of NSF. And then early 1990, this is very important, World Wide Web is started. So hypertext, okay, web page, okay, HTML, hypertext markup language used to make the web page, and then HTTP, hypertext transfer protocol used. So Berners-Lee is the father of the World Wide Web. He designed and made this HTML HTTP protocol. And then Mosaic and later Netscape. This is the first web browser. Okay, this is a significant invention. Okay, for World Wide Web. And then late 1990s, commercialization of the web. Late 1990s, 2000s, okay, early 2000, more killer application, instant messaging, peer-to-peer file sharing, BitTorrent can be used, and network security to forefront. Okay, so and then backbone link running at gigabps. So this is a web browser. This is Mosaic first. Okay, worldwide the web client browser, and then later on this is okay advanced to evolve the Netscape. Okay, Netscape is this one. So I used the Netscape. Okay, when I undergraduate at SKKU. After that, Microsoft, the Internet Explorer, and then after that, Google. Okay, 1996, something like that. So Google okay, started to make their own web browser, Chrome. And 2005 through present, more new applications. Internet is everywhere, every day, every time, everywhere. So 18 billion devices are attached to the internet. Okay, so 2007 iPhone is invented by Apple, by Steve Jobs. This is a significant moment. And the aggressive deployment of broadband access is allowed, and increasing ubiquity, everywhere, anytime, connected to high-speed internet using 5G, 4G, Wi-Fi. Okay, and then emergence of online social network, Facebook, nowadays Meta, right? So Instagram, TikTok, something like that. 2.5 million users are using this SNS service, social network service, right? And service providers like Google, Meta, Microsoft create their own content delivery network, The bypass commercial internet to connect close to end user, providing instantaneous access to search video contents. And the enterprises run their service in cloud, like Amazon Web Services, AWS, and the Microsoft Azure cloud service. This is the cloud service, Amazon Web Service, AWS, right? So many clients using AWS for their service. So IPTV, television, web client service provider also using this kinds of AWS, making their own server. So elastic service, cloud computing service can be provided by this Amazon, the cloud. Let me summarize chapter 1 today's class. We've covered a ton of material: internet overview, what's a protocol. Also, we are looking at network components like network edge, access network, core network. Also, we see the comparison between packet switching and circuit switching, internet structure. Also, we saw performance metrics such as loss, delay, and throughput. And also, we studied the layering architecture, the motivation and the structure and service model. And we looking at the security. And finally, we reviewed the history of the internet. So you now have basic foundation and knowledge, such as context, overview, vocabulary for networking study. More depth, detail, and fun to follow. Additional chapter 1 slides. This is OSI, International Standard Organization to make network the layer architecture, OSI. OSI stands for Open System Interconnection Reference Model, And two layers are upon the internet protocol previously, right? Like presentation and session layer. So presentation layer is to allow application to interpret meaning of data, such as encryption, compression, machine-specific convention, like data byte ordering, big endian and little endian in computer architecture point of view, message byte ordering. And session layer is a synchronization, checkpoint, recovery of data exchange, like a database service. So two protocol layers omitted for simplicity. These services, if needed, must be implemented in application layer. And lastly, WireSock is a network packet analyzer, packet sniffer. So the wired or wireless. So the WireSock can capture, using pcap library, and the packet analyzed can be used promiscuous mode. Okay, and then we can analyze packet in the network. Okay, that's all. Thank you for your attention. If you have a question, please let me know. Thank you.